Okay, student, welcome to this section about the substitution method. So, in Calculus 1, you have learned the elementary integration formula. For example, if you have u to the power of n du and you want to do the integration of, for example, u squared du, all what you need is you add 1 to the power and you divide by the new power. So the answer will be u3 over 3. So if we have u to the power of n, the answer is we just add 1 to the power and we divide by the new power. Of course, this happens all the time except if the power from the beginning is -1, which means u to the power of -1. This will be the same as 1 over u, and this is the famous ln of u. Same thing if we don't have any x, any u, anything. If we have just integral of 5 du, the answer is just straightforward 5u plus c. Those are what you have learned in Calculus 1, the elementary one, and we have seen also the e to the u. We have seen the tan inverse, sine and cosine, and so many of them. Please revise those integration from Calculus 1 because we will heavily use them in the first half of this course from Calculus. Now, in this section, substitution method, is we will see an integral which is not from this list, which is not a direct integral from this list where I can look up and find the solution. So we have to do substitution, we have to do something in order to change it to something in this list. So the idea is to change complicated integral to one out of this list, and then we use one of those elementary one to find the answer. And that's exactly what we mean by the substitution method. So the substitution method is to replace a relatively complicated integral by a simpler one. What do I mean by a simpler one? For example, one from the list. Now, usually the setting where we use the substitution method is when we have an inner function. Inner function, it means a function inside another one. So this is an inner function. And the derivative of the inner is also there. So we have two things to keep in mind. It should be an inner function, and the derivative of this inner function is also written in the integral. So I'm just writing down here is my inner, I should have an inner function, and the derivative of the inner function, it's appear in the integral. Now, how I'm going to use the substitution method, I will call this one to be u. So this will be directly du. And the final thing, it will be integral of f of u du. Now, the first thing you have noticed is I don't have x anymore. I just have u. And this seems to be a simpler one. It's just f of u. Maybe this is from the list. And hopefully this is from the list. And it should be from the list. And if this is from the list, we can finish the question easy. Okay. Now, let me put this one into an action up here in the first example. So here is this one. Now, if you look at this integral, you will see that we have x e to the x squared. This is not from the list. Now, the first question, ask yourself, do you see an inner function? A function inside another function? Well, you can see here we have e, and we have inside the e x squared, because usually this is just ex. Now this is ex squared, so it's kind of having x squared inside the e. So this will be my candidate to be u. So I will say u equal x squared. Now how do I check if this is a correct choice? Maybe something else should be u. Take the derivative. The derivative is 2x. First of all, let's all agree we don't care about the numbers. This 2, forget about it. Don't look at it now. Just keep it hidden. Look at x. Do we have x alone in the integral? Yes, we have it. It's here. So this, by 99%, this substitution will work perfectly fine. If we have the derivative of the inner is almost there. What do I mean by almost? I mean we don't care about the numbers, the rest are already there. So what do we have here? We have next step, we need to find du, which is 2x dx. But actually what I'm looking for is dx. I don't want du here, I want dx. So how much dx? We have to find it from this equation. In order to find dx alone, you need to take 2x to the other side. And if you take it to the other side, since it's multiplication here, it will go by division. So you get du over 2x. And I think now we ready to go. X e x squared dx equal to integral. The first x we don't care. Now what is e to the power of, instead of x squared I will write u. Instead of dx I will write du over 2x. Now if everything is correct, x will be cancelled with all the x's. So we have x get cancelled. Of course we have 2 here, it will go outside. So we get 1 over 2 integral of eu du. And that's clearly the final answer. So it is 1 over 2 eu, it's the same as eu plus c. And the last step is we have to return this back into x. We don't keep it as eu plus c, we need to return it back into its origin, which is 1 over 2 ex squared plus c. And that's the final answer. In the next video, we'll continue applying the substitution method to different type of integrals. Thank you very much.